Okay, so hello everyone and welcome to this new video. Today I want to show you a project that I've been working on for a long time actually, and it aims to be basically a computer museum but online and with the added features of basically having interactable computers, so basically just emulation but with an added layer of let's say both complexity and emulation. So we have that you can now interact in a 3D environment with them with maybe real timing, so something which is better than standard text-based emulation, and also allow you to, let's say, have to load maybe physical media, etc. So it wants to add another layer of interaction to these emulations and a new way to live the history of computers. This is a prototype for the website in which you will have the emulators at a startup. Right now it's not published yet. I want to publish it soon in the next months, and it will be completely open source. So I hope that maybe someone will want to collaborate on this, and I'll launch. For now there are the PDP-8, the PDP-11 fully, let's say, usable in some aspects. The most complete one is actually the PDP-8, which we will see today, and in particular we will see how we can completely, let's say, assemble and run a program entirely inside this emulator. So we press launch and we get into this environment. Ignore this, which is a test. And so we are here in the room in which we have our computer, which in this case is the PDP-8, in particular basically one of its earliest revision, which is basically the straight 8, one of the first version, if not the first version, of around the 1960, along with its main standard input-output device, which was an ASR33 from Teletype. And so we need to first of all load the program into memory, the assembler into memory, then run it using a program that we've written, and then we can run the output into the machine. So first of all, what you will need to do is you will need to load the assembler, and to do that you will need to do two things. So first of all, let's power the computer, and you will have to have in memory the rim loader, which will then be needed to load the pin loader, which is the one which is actually used for let's say more complex programs, and the rim loader will be basically toggled in by switches, and then it will just remain in memory because it was persistent memory, it was ferrite core memory, and then after that you would have to, if you didn't have it in memory, also the pin loader through tape, and you can do that in the emulator, but for the sake of time we just have some useful buttons that just load them into memory. So let's just load directly the pin loader, which will load basically a 7777, and we can actually already start it. So we basically set 7777 as the address. We press load address and we press start, and as you can see it is running. And so we can just exit from the front panel, and here we need to actually provide the paper tape. And this emulator, you can just load any arbitrary paper tape. I've already prepared it here, the actual PAL assembler, and we can just load with a paper tape in hand by pressing here with the tape in hand. Then we actually need to power on the teletype, so we go here into line mode. So now it is actually connected to the computer, and we enable the reader by just having it go to start, and now the actual program is loading the data into memory. So this is a really long process, it's a really, let's say, big program, and we can actually skip a bit of the timing by doing a setting, which is this one, instant paper tape, which basically allows for the timing, let's say, constraint given usually by the ASR33 to be avoided, because all of this aims to be mostly time accurate also. So right now the PDP-8 is running at its normal speed of 300 kHz, but also the ASR33 is, let's say, tied to its mechanical speed, but if you do instant paper tape, the ASR33 will just go as fast as it can, and so it will be much faster. And now we also load the actual program, which I already prepared on another tape, which is this one, the program file, which is just a tape which contains the listing, so basically an ASCII file with all of the listing of the program that we will actually compile, and I will show you later. And so we can see now that the tape is being read. Okay, we are done. We can see that build loader paused, which means that it finished loading the tape. We go into free, so we can remove it, and we remove this, which we won't need anymore because now the actual assembly is loaded into memory. And now I'm gonna show you the content of the program that we are gonna assemble, so we can put it here. We go into the start position. Well, actually, let's just stop for a minute. Let's disable this on paper tape because we're gonna go into local mode and print it out. So we can go to local mode, and we go to the reader. We start the reader, and it's gonna read the actual program which is on the tape and print it. So this is just a simple echo program, and so we can just now release it. Actually, we need to put it back because now we are gonna use it with our assembler. So our assembly is now loaded in memory at position 200. If you see me moving like all of these switches like this, is because on the bottom right corner you can see some keybinds that are in some of the contexts, let's say. So like in the paper tape reader and puncher there will be some, here there will be other, when you're free roaming there will be other. And so the actual program was loaded into 200. So we set the program counter as 200, and then before starting we need to set some flags. In particular, we need to do two passes because we need to do a first pass which basically just defines the symbols, and then we need to do the second pass which actually create the output, so the actual runnable tape. And so we need to set bit 1 of the switch basically register here, and this is the position 1, let's say, because for the DEX standard with this computer was that the most significant byte is actually byte 0 and the least significant byte is byte 11, so it's basically reversed with respect to what we usually use now. And so now we have this basically sense switch set to 1, so we know that it has to do the first pass. So we start it, and now it's not doing really much anything because it requires of course the tape. So we start it, and now it has access to the tape, and it will start reading and doing the first pass on our actual tape. Oh, I made an error. Okay, so I had actually forgot to set it to line mode again. So we get back to line mode. So we're now on the reader, and now we can enable it. And now it's being read by the computer. It will read the tape, do the necessary computation, and then the output on the actually ASR should be like the symbol table, which is just start in our case, and then now it should pause when it's done, and so now it's paused. And now we can just remove the tape from here and actually put it back because we need to do the second pass. And for the second pass we actually want to start the puncher because we want to save the output. So let's just remove this for a moment just to have a better view of this. So we go to the puncher, and here we need to do so as you can see here on the bottom right corner we can see some keybinds, and we press L to load an empty tape, and then we can just turn it on. So now it's turned, and anything which is sent to the ASCII by the computer will actually be printed on tape 2. And so now we get our reader like actually listing back on the reader. And we do this because as you can see, it's a bit for now in the UI there is a bit of overlap, let's say, and this actual strategy of using these spools, which are basically invisible, is because there is no physics in the engine, so it's not straightforward how to make actual good looking paper tape handling. And so actually we need to turn off the tape puncher first, because otherwise the produced tape will have some codes which are not well handled by the binary loader. So now we have it on off, and we need to start the second pass. So this time the sense switch bit 0. So first of all, actually the program counter at 200, sense switch at 0, and we start. And now we need to start the actual puncher, and I'm gonna print some leading characters, and now it's waiting for the actual listing, and so we're gonna just start it. And now we should see the actual printing on the paper punch as the program gets compiled or assembled, really. Okay, so this is some leading tape, some trailing tape, which is printed, and so now we can actually remove everything because it should have stopped. Yeah, pause. So we remove this old tape, we don't need this anymore, and now we have this tape that we can remove by going here. I turn it off, I press the release button, and then with E I can just take it into my hand, and now I'm gonna just place it back onto the reader. And here I can start again the bin loader that we used at the start to load the assembler. And so I just started. It's waiting for the tape which is not in the start position. So I go start. And now it's gonna start with the tape that we just assembled. Okay, it's done and it's paused, so it correctly recognized basically the format of the bin tape. So we can actually now remove these two. We're gonna put it here, and now in theory we should have at position 200 our program loaded, and we can just start it. And I didn't say it yet, but the program that we loaded is just a simple echo program, and so we can just test this. This is just my bad typing, but this is working. Okay. And so we correctly assembled and then run our program. And another nice thing that we can do with this emulator is that of course we can save them to file and we can then load them back. So between saves you can just create programs, save them, and then load it into another session and use them again. And so for example here, if you press P, you can just save it. Let's call it just assemble.tp maybe, and we can just save it. And you can see that here, if you can just list it with this script of mine, we can just see this is the exact paper tape. We see the leading characters that are needed by the bin loader. We see the program, we see the actual, this should be the checksum I believe, and then here are the trailing characters. And so we can just then load it back into another session and use it again, and so on, or also experiment with other tapes that can be just taken by you on the internet, like Deco's tape, etc. So this allows for experimenting, creating your own program. It should also be, let's say, compatible with other emulators, but also with the real thing in theory, but some testing will be done in that regard to not just make assumption. And so this is it. I hope I'm gonna be able to release it soon, and I hope if you watch this you'll be interested in trying it and playing around with this. And if you have any suggestion, really maybe want to help in the development into the 3D modeling, there are a lot of work to do. It will be open source when released, so there will be opportunity to work on this, and you know, any feedback is really welcome. Please let me know what you think about this, what looks wrong to you, what should be added, what you would like to see in something like this. So please let me know, and thank you for watching, and I hope you are gonna have a good day.